Okay, so we are here today to talk about and walk through the essentially the librustzcash crates. The These are the crates that are maintained primarily by the ECC core team, although we are, as always, actively soliciting contributors. And yeah, this is just a walkthrough to get everyone acquainted with the structure of our Rust crates and what you can find, expect to find in each of them, and so forth. So we're going to start. This I've just updated the librustzcash README with some high-level summaries of what each of the crates do, but and added this graph of dependencies so you can visually see how everything relates to one another. And we're going to work through this graph kind of from the bottom to the top. So at the very bottom here, so there's a set of crates that are in the librustzcash library or repository itself, and then there are other Zcash crates that are maintained underneath the Zcash organization, GitHub organization, but which are not part of this repository. I have them in this graph because I want it to be sort of readily visible where to go for most of what you'll need. Now there is also a whole stack of other crates for the proving systems, the circuits, or the circuit utilities, and so forth that sit underneath these that I'm not going to talk about today. What I'm going to talk about are basically the crates that are going to be of primary interest to developers who are working on things, using the higher level APIs to the Zcash crates. So the yeah, and I am recording this for those who just joined. So it will be possible to we'll edit it up and post it once this is done. All right. So the at a high level, there we have our crates divided into sort of several different layers. There is a layer that's up here of wallet support crates. Those then depend upon a layer of crates that handle essentially transaction construction and transaction serialization. And crates at this level are used both in say the mobile wallets, which are using these crates up here, and in Zcash in the Zcash wallet at present. Then these depend upon lower level protocol and utility crates. So we have three primary protocols, and the Zcash proofs crate over here is essentially Sprout, but we have the transparent protocol, Orchard, and Sapling. We have these are the crates that have in them the Orchard circuit, the Sapling circuit, and then essentially all of the transparent protocol with the exception of the Zcash script implementation. And we will likely want to move once the Rust implementation of Zcash script is complete, we'll probably want to move that also into the Zcash transparent crate so that it really becomes kind of an equal peer to the Orchard and Sapling crypto crates. And then below that level, there are some crates that are, so we have common types and protocol constants in the Zcash protocol crate. We have address serialization that does not depend on any protocol types, so that it's usable, serialization and parsing. This is intended for use by, we use it both internally, but also it's intended for use by anyone who might want to be able to, say, parse a Zcash address and just get out a unified address and get out the transparent component without having to depend on, for example, having the orchard, all of the orchard dependencies and curve types and whatnot in their dependency tree. So this Zcash address crate is really useful for also, for example, it compiles to WASM, so you could use its parsers in a web context and so forth. Then we have some low-level sort of utility and encoding crates. So F4 Jumble, which is used for unified address encoding, Zcash encoding. This is Bitcoin-derived binary encodings that are used in Zcash transactions and so forth. And then all of these that I just described are listed in the README of the librustzcash crate down here. So with that sort of high-level summary under our belts, I want to go through and start looking at digging into a little bit more detail with respect to what's in each one of these crates. And I'm not going to cover the bottom part of this graph in this detailed walkthrough. These are just going to be, we're going to use types from them, but we're not going to look at them internally. So the first thing we'll look through is the Zcash protocol crate. If you're building something, at virtually any level of the Zcash protocol, you're going to need things like the consensus branch ID, so the consensus module here has types for these sorts of things. So consensus branch ID, what network you're on, main network, test network, and then of particular interest in this part of the stack are the network constants and parameters traits. So the network constants trait, for a given network, these are all constants that you will need if you are generating or parsing Zcash addresses. And then the parameters for any given network, you'll want to know things like what is the activation height and utility function for is a particular network upgrade active as of a particular block height. So just a low-level set of tools for getting the network parameters that you might need. And this is also a essentially zero dependencies crate. The other important things to be aware of in this crate are there are value types. So bounded type-safe representations of Satoshis and Zap balances. The difference here is that Satoshis are types in Satoshis. Zap balance is when you perform a subtraction of Satoshis, you may get a negative value, and so that's represented by a Zap balance. So, for example, when we have the value balance in the sapling bundle or the orchard bundle, those will be represented using a Zap balance type. All right. The other thing that's in here is the some memo types. So low-level memo byte representations, and then higher-level memo types that can be text memos or future memos or arbitrary byte memos. And this as ZIP 231 is implemented, this is where you will see the memo types for memo bundles also come in. The other module of note for testing is the local consensus module. This provides a type where you can just set your own activation heights for network upgrades. So if you need to build out, some sort of test network or reg test utilities, that type is often useful. All right. Any questions about this crate? If not, we will go on and we will move up the stack a little bit to Zcash address. All right. So the idea of the Zcash address crate is that it provides it is a one-stop shop for let's see. Yes, that Zcash protocol memo module is where the low-level types for memo bundles will show up. Okay. So now back to Zcash address. This crate is where we provide parsing and serialization for all Zcash address types that are supported. This diagram sort of shows what the intended use is that you get a Zcash address as a string, you parse it to a Zcash address type, and then you convert it to a custom type. Now, later on, we will talk about the Zcash keys crate, and that's where these custom types are implemented. Zcash address is essentially a wrapper around chunks of bytes that are not then further interpreted. These custom types are, for example, the actual protocol specific, curve points and so forth in type safe wrappers that allow them to be used as recipient addresses within the protocol. But we make this further separation between strings, Zcash address, and these custom types because we want, for example, an exchange that is wanting to parse Zcash addresses to be able to do so and grab out, for example, the transparent part of a unified address without having to depend on all of the protocol level crates. So without having to depend on Orchard or Sapling Crypto or any of those things. So these are basically, Zcash address is string to byte transformations. Zcash address is a little bit tricky to use. At a high level, these are the important operations. When you get into implementing these traits, it's probably good to go and have a look at the existing implementations that exist in Zcash keys. The best option is just to use the Zcash keys crate if you're working with protocol types that. But these traits that are listed here are implementable for if you need to do something with parsing or serialization in some other context. Those are not my dogs. Those are someone else's dogs barking in the background.
Hello.
So
maybe Gustavo?
Salvia, you're not muted.
Yeah, I think I can mute that. Okay. That works better. Gustavo, you'll have to type to me if you want to speak. All right. So then, we've been through there.
That muting doesn't seem to have worked.
Oh, I guess it only worked for me. No. All right. Well, I'm going to carry on. At least it won't be in the recording because I can't hear it. But I'm not able to mute Gustavo.
For everyone else, if you click the three dots in the blue square, it's the upper right of Gustavo's icon, then you can turn down his sound.
All right. Continuing on. All right, so now we've gone through Zcash protocol and Zcash address. Another relatively low level crate that we can talk about briefly is zip321. This is another just parsing and serialization crate effectively for zip321 payment requests. These types, the payment and transaction request types, will become important when we go to look at the Zcash client backend crate, because in Zcash client backend, all of the transaction construction now is based upon zip321 transaction requests as sort of the when you go to construct a proposal for a transaction, you do so using a zip321 payment request. Otherwise, this crate is it also is intended for example, cross compilation to WASM, so that web pages can use zip321 payment requests without too much difficulty. And yeah, that's enough for that one. All right. Next piece, recently factored out from the rest of this. This crate was previously part of Zcash primitives, but as part of our partially constructed Zcash transaction support for use with the hardware wallets, the Zcash transparent support has been factored out into its own crate. And the important things here are we have address types, we have a builder. This is going to be used internally by the higher level transaction builder that we're going to look at in a minute. So you usually won't be using that directly. And so builder and bundle types for inclusion in the Zcash transaction. PCZT support. Now this is protocol specific PCZT support. So we have things like pieces that can be used to construct the transparent, construct, update, and partially sign, I guess. Yeah, in the updater is where signing or in the updater role is how signing happens. So those are all pieces that you use if you're building the transparent parts of a PCZT. All right. Now moving on to these two crates, Zcash primitives and Zcash keys, are essentially the crates that if you are if you're implementing just about anything having to do with the Zcash protocol, you'll be using these at some level. So we're going to look at these in a bit of detail. So Zcash primitives has been split apart over time, and we're reducing it down to a pretty specific core. So we have in here, just at a high level, block header types. We can sort of ignore so consensus and constants are re-exports of Zcash protocol types, but the important part of Zcash primitives is the transaction module. there. All right, so this is where you're going to find all. So first off, the transaction data type. So the fully constructed Zcash transactions. These are signed transactions with their TXIDs and so forth. Transaction data is a lower level type that is used in the construction, proving, and signing process. And then essentially everything in this module is intended for building and then signing those types. So, for example, this is the level at which the Brave wallet developers are working. They are using Zcash primitives and Zcash keys, but they're not depending upon the higher levels of our wallet support stack. So this is sort of Zcash primitives transaction type is the basic usable unit of Zcash functionality. We have a builder that is just a builder interface that allows you to, add orchard spends and outputs, add sapling spends and outputs, transparent inputs and outputs, figure out the fee, and then actually construct the transaction. So build is a function that does all of the proving and signing at once, and you give it a set of keys. Build for PCZTs allows you to construct a PCZT that you can then serialize and then perform proving and signing operations on separately. I guess the one thing I'll note, build result. So when you build a Zcash transaction, the inputs and outputs for the shielded protocols are shuffled. This has been just part of the approach to, a small amount of information hiding sort of throughout Zcash's history. And so because those things are shuffled around, when you build the transaction, you need to know, in what slot a given input that you had added eventually ended up. And then, are there any questions about the Zcash primitives crate? Alfredo, go ahead.
Yeah, so I have a more general question that might be trivial, I guess, but I'm going to ask it anyways. I know people is probably used to it, but it was ever considered to rename some of the crates of the library itself? I see like it says too much Zcash everywhere. And yeah, like for example, Zcash client backend, could that be renamed to just Zcash client, for example?
Well, it's not a
point. Would you ever consider that? Sorry, go ahead.
I mean, we could rename some of these things. Zcash primitives in particular could probably be renamed to something like Zcash transactions, although it also currently has block and block header stuff in it. Zcash client backend, we're gonna talk about that in a minute, but it is naming is hard. Zcash client backend is a crate for people building Zcash clients and having but it's not a full Zcash client in and of itself, right? Because it needs a storage layer. So we'll talk about that in a minute. I think that the most important thing is really to have the documentation of what each of, high level documentation for what each of these crates provides, The names are adequate. They could be better, perhaps not worth changing. But if people have really good naming suggestions, happy to listen to them.
Good. Thank you.
All right. Any questions about Zcash primitives?
I asked a question, does the version of the crate you use matter? Like, do you have to keep track of that, or does it not matter?
Yes, versions of the crates do matter in several ways. So when we make a change to anything that has bearing on consensus, that will usually begin with a Zcash protocol major version bump. And that will then include the consensus branch ID and so forth. And then because there's a bump to the Zcash protocol crate, then everything above that will get a major version bump. We also, we follow Semver in these crates. And so we will make major version bumps that are not bumps due to changes in the consensus protocol, but just because we have breaking changes to the APIs. Unfortunately, so a downside of Semver is that it doesn't allow a sort of major version, minor version usage pattern. Ideally, I would have the version of these crates be have a upper major version that was bound to the consensus version. So, NU5, NU6, NU7, and then a minor consensus or a lower major version that was just for API breaking changes. However, we don't really have that option under Semver because any yeah. And anyway, so best advice is to try to keep up with breaking changes with version changes as they go along, because we do not backport consensus breaking changes to earlier crate releases. So for example, when the NU7 consensus branch ID is added to the Zcash protocol crate, then you will need to update to whatever level of the stack you're using above that. And there may be, both API changes that have accrued over time since the last network upgrade based release and the network upgrade changes. So it's best just to try to keep up with the latest version of the crates.
So, like a follow-up question, if I'm a new dev coming into the ecosystem, how would I know where to start? Do I just automatically go to the newest version and that's the recommended setup?
Yep, absolutely. Yeah, you use the latest version and stay on the latest version if you can. All right. Anything else? Any other questions before we move on from Zcash primitives? Okay. So we've been through the stack from Zcash protocol, Zcash address, zip321, and Zcash transparent, Zcash primitives. Now we're going to go and look at Zcash keys. So Zcash keys is support for protocol level Zcash address types. So as I mentioned before, the Zcash address type of the Zcash address crate has just parsing. This is where we have actually, for example, the unified address type. And the high-level address type, which is an enum that covers sapling addresses, transparent addresses, unified addresses, and text addresses. So this address type is likely the one that you will want to work with in your libraries. If you're building, if you're building a wallet, for example, this is the correct address type to use. And then similarly, Zcash keys. Dara Emma.
Yeah, so when I've been trying to implement conversions between different address types in different libraries, I've always found that a difficult thing to do. Has that improved? Because I think that was when that was before the current version of Zcash keys and Zcash address.
So it has improved somewhat. What I will say is that we need to document the use of the Zcash address crate better so we need to document better how, for example, the address type can be used with the Zcash address crate for serialization. So if we go and take a look here at the address type, there are conversions to and from Zcash address, and then you would use that Zcash address type for encoding to and from strings. There's also, there are also direct encoding and decoding methods here that are essentially just convenience methods around that two-stage transformation. Paku.
Oh yeah. One thing that I always came across when using these crates is that, to what Dara said, I think that there are two challenges. Like when you're new to Rust and you don't know a lot of like how generics work, like this crate in particular, since it needs the parameters to actually give you the right results for the network, for the consensus parameters you want, like mainnet, testnet, regtest, for example. Those are parameters. So if you're not familiar with that, it will be kind of a challenge. But then also, I guess the second challenge that you haven't spoken about is like maybe there's a learning curve on the key hierarchy and what can be converted to what, and what do you need to use on what keys you need for your use case, for example. Like I think that's the APIs are pretty clear, but the concepts they have are kind of like the challenge, maybe not the APIs themselves.
Yeah, I absolutely agree with that. There's, the Zcash protocol is a complex beast. So with that in mind, we should probably go and walk through the actual keys module a little bit here to sort of talk through where to start. So if you're building a wallet, one of the things that you're going to need is to manage spending and viewing keys. So the unified spending key type is the high level place to start. So this is, you can create a unified spending key using zip32 derivation from a particular seed for a particular, this is a BIP32 level account ID type. So this comes from the zip32 crate. It's basically just a bounded wrapper around an unsigned int. But so again, this is zip32, so hierarchical key derivation, and you start from a mnemonic. From a mnemonic, you'll use something like the BIP39 crate to get a seed, and then from those seed bytes, you can create a unified spending key. That unified spending key, so you'll see that everything in this crate is is the per protocol support is based on feature flags. This is so that this is usable by an entity that doesn't want, for example, to pull in the sapling dependencies. They can have the transparent and orchard feature flags enabled, and then they don't have to personally review the entire sapling dependency hierarchy. This was pulled out in order to support Brave's use, because Brave does not support sapling, and they don't want the sapling crates anywhere in their dependency tree, because they don't want to have to review them, because they have strict review policies. So from a spending key, you can get either the individual spending key parts, or you can get a unified full viewing key. And then, so unified full viewing key, from there, you can drill down, you can get either the individual full viewing key parts, or you can drill down to the unified incoming viewing key. And incoming viewing keys are what give you the capability to derive addresses. So the hierarchy is spending key, full viewing key, incoming viewing key, and then given a diversifier index, this is translated to either a sapling or orchard diversifier index, and if possible, a transparent, BIP32 transparent child index to actually obtain an address. When generating address, you'll be asked to supply optionally a unified address request. If you supply none here, then all of the receivers of the unified incoming viewing key, or all of the key items, so sapling, transparent, orchard, whichever of those items the incoming viewing key has, will be used to generate an address. But you can specify, this type is changing in the next crate release. So previously it was just whether you want an orchard address or a receiver, whether you want a sapling receiver, whether you want a P2PKH receiver. In the next crate release, these are going to be tri-state, where you can either say an orchard address is, or an orchard receiver is either must be omitted, is allowed if available, or must be included. So sort of require, allow, and omit will be the tri-state options there. And this is useful, for example, if you need to generate an address, but no valid sapling diversifier exists at that address, because the sapling diversifier space is only half of the diversifiers are valid, then if you say, well, a sapling receiver is allowed, then you'll get one if you can generate one. Otherwise it won't. Anyway, and there's going to be another release of these crates. I think likely this week. Major version releases with breaking API changes. All right. Any questions here? I know we went through that relatively quickly, but we've got a bunch still to get through, and time is a little bit short. Everybody comfortable with Zcash keys? All right. On up the stack. And we'll take a brief diversion to the PCZT crate. Oops, let me open this. All right. PCZT crate, this is the partially constructed Zcash transaction format. This was built as part of the Keystone Wallet support, and this follows the PSBT partially signed Bitcoin transaction format relatively closely, or at least it's heavily inspired by it. And in particular, the thing that is most inspired by it is the notion of these partially constructed or the roles that are involved in creating a transaction. So it's useful to go through this documentation. I'm not going to take the time to go through it now, but there's a process whereby you construct a PCZT, you add inputs and outputs, spends and outputs to it. Then you finalize it for I/O, so that means that all of the spends and outputs are fixed. Then you can update it to add information for signing. You have then usually in parallel proving and signing happening. Dara, Emma, can you mute, please? I'm hearing your keyboard. And then the combiner brings everything together. The spend finalizer is a role that then combines the transparent signatures, and then you can extract from that PCZT the final transaction. So in here, so each of those roles is represented by a separate type, and these then where is it? So a good way to understand how to use PCZTs is to look at go look at the implementation in Zcash dev tool of the PCZT commands. So this is a reference implementation for how to do essentially each step of PCZT construction. Okay, we'll move on then to Zcash client backend. So Zcash client backend is an opinionated crate for building wallets. The essential idea here is that there's a lot of complexity in the Zcash protocol, and it's a lot of work if you use the lower level crates to build a wallet. And so Zcash client backend aims to take a bunch of that work off your shoulders. So the major things that this crate handles are it provides utilities for scanning the chain. Right now, that scanning is just built around using the light client protocol. However, it's currently being adapted for full node scanning atop Zyno. It provides high level utilities for fee calculation, for handling ZIP 317 fees, and it provides high-level utilities for transaction construction based upon ZIP 321 payment requests. And we'll go through a bit about how all of those pieces fit together here. So the core of the Zcash client backend crate is really this data API module. So the idea of Zcash client backend is that you can build a complete wallet using this crate if you bring your own storage. And the data API module defines all of the important traits that storage backend must implement in order for the rest of the wallet functionality to be provided. So so for example, the scanning logic just requires a wallet write that can also provide wallet commitment trees, and then it can provide it can do all of the rest of the hard work of scanning, trial decryption, etc. Just based upon those. And when you scan the chain, then the the notes that are relevant to your wallet and the will end up in that backing store, along with the correctly updated note commitment tree information and so forth. Now, Zcash Client Backend is an opinionated crate. So if, for example, you wanted to use a different note commitment tree implementation than the one we choose here, you would be somewhat on your own. We make choices that we think are good, and hopefully, hopefully we have the right level of generalization for most users. This is the API that then also backs, for example, the Edge, Nighthawk, and Unstoppable mobile wallets. All right. So core traits, I'm not going to read through, but really important traits here are input source, wallet read, wallet write, and wallet commitment trees. If in your wallet you just implement the input source trait, then you will get enough functionality to be able to use essentially all of the transaction proposal machinery. That includes creating a transaction proposal from a payment request by choosing inputs and computing fees, ZIP317 fees, and so forth. You can get to a complete transaction proposal. I should probably stop at this moment and talk a little bit about the proposal type. So the essential idea behind the proposal type is that when you go to create a transaction, from the perspective of a user, it's a two-step process. There's the step where the user either enters information about who they're sending to and how much, or the user scans a ZIP321 payment request. And then the wallet goes and chooses inputs, computes fees, and presents a proposal for that transaction to the user. Now, that proposal will contain enough information for the wallet front end to inform that user about what impacts executing that transaction will have upon that user's privacy. So for example, if you're creating a proposal that involves spending some sapling inputs and producing some orchard outputs, then you'll be revealing information about the value of the total value transferred between pools via the transaction turnstile, because that then becomes, or via the pool turnstile. Because that information then is publicly revealed, that means that that has privacy implications for the user. And so it is important that that we sort of have this two-step process. Now, a wallet may choose to say, well, if all of the inputs that are available are sapling and there is a sapling recipient address, the wallet might choose to say, well, I'm just going to keep everything in the sapling pool in order to minimize the information exposed. Or the wallet might choose to say, well, I want to migrate users to the Orchard protocol as quickly as possible, so I'm going to move all of the value of the sapling notes across the turnstile at once, and then I'll just inform the user that they have to approve, that they have to consent to that being revealed. But in either case, there's this process of the user puts in information, and then the user consents to the actual transaction that's being constructed. This proposal type can be serialized to a standard protobuf encoding, and that's what we use when passing the proposal, for example, across the FFI for mobile wallets or for other wallets where you have to do stuff across the FFI. All right. Any question about transaction proposals? All right. So as I noted earlier, the input source trait is the trait that gives you that much functionality. So then, wallet read and wallet write are wallet write is the trait that gives you the ability really to set up a wallet and to use the scanning support that's provided in Zcash client backend. So you can see there are a bunch of pieces here. You can create accounts. You can import accounts from UFVK based accounts. The put blocks and put receive transparent UTXO methods are those that are used in scanning, as are stored decrypted TX. When you're doing transaction construction using this crate, you'll use that will internally use store transaction to be sent, and so forth. So this is the trait that essentially powers the real wallet functionality. And then wallet read provides a read-only view over that data that is constructed and persisted via the wallet write trait. And this provides just a bunch of methods that are useful in the case that you're building a wallet. So if you are using the wallet read and wallet write traits, then let me go back up to the data API module. The submodule that you will likely be interested in using here is the wallet module. So this provides the high-level sort of user-relevant methods that are that are the core of wallet transaction creation and sending. So the important ones are these three propose methods. So those propose shielding, propose standard transfer to address, and propose transfer, and shield transparent funds. Those methods all result in a proposal being created, and then create pieces of T from proposal and create proposed transactions are the methods that you use to actually convert that proposal, create proposed transactions, does all of the signing and proving internally, create pieces of T from proposal, then creates pieces of T that you can then run the signing and proving processes on. And then once you've done that, you can use extract and store transaction from pieces of T to get out the fully proven, fully signed transaction that you can then submit to the chain. Questions at this point? All right. The chain module is the other one that you'll likely be interested in here. So the core the core operation from the chain module is the scan cache blocks function. This is a little bit of sample code for how to use it. But yeah, you can see it's actually the only top level function defined in this module. Scan cache blocks, takes a block source and a wallet database, and then scans the chain from a given, scans a certain number of blocks starting at a given block height, and does all of the interactions that are necessary with the wallet database to store notes that are for the wallet and update note commitment trees and so forth. Okay, we're getting close to the end here. Yeah, the scanning module in Zcash Client Backend. This is just a bit of support functionality for the out-of-order scanning that is supported by the wallet backend. This is what allows you to have only partially scanned the chain, but spend whatever notes have already been discovered that are yours. And that's kind of it for Zcash Client Backend. Anyone have any questions there? All right, so we can go back up to the top of the stack, and Zcash Client SQLite is the last thing we have to talk about. And oh, Paku, go ahead.
Yeah, maybe this will answer the question, but how should wallet developers use Zcash Client Backend if they want to implement their own scanning logic? Let's say I want to port Warp Sync to work with Zcash Client Backend or any other or Blaze Sync or whichever other mechanism I can come up to. What should I do? What are the recommendations?
So if you're porting a different sync algorithm, you could certainly use Zcash Client Backend. It might be that you might need different operations on the wallet write and wallet read trait than the ones that that we support. So there are two ways you could go about that. One is that you could create a trait extend of your own that extends from wallet write to add whatever additional operations that you need. Otherwise, if it's sufficient just to use, if Blaze Sync or Warp Sync or whatever, if the operations that are exposed in wallet write are adequate, then you can just use it directly, and then you could use the rest of a storage layer that supports wallet write to handle those. Obviously, if you have if you need different operations, then you would also need to extend a storage layer to support those additional operations. So for example, what we're getting to right now in looking at Zcash Client SQLite is Zcash Client SQLite is an implementation of those wallet read, wallet write, input source, and block source traits from Zcash Client Backend. It exposes very little itself. You may now, if you write your application directly atop Zcash Client SQLite, and not just to the general Zcash Client Backend interface, then you can use additional functionality that is exposed in Zcash Client SQLite that isn't part of those interfaces. The only important things there are so Zcash Client SQLite provides a wallet backend where there is a SQLite database. We provide database migrations for that database, and that database also exposes views over the data that are not expressed in the Zcash client backend traits. Now, the reason that we consider those SQL views to be a part of the Zcash client SQLite public API is that it doesn't make sense for us to attempt to implement a full query language with all of the expressiveness of SQL in a Rust API and expect all of the implementers of Zcash client backend to then be able to implement that interpreters from that Rust API query language to SQL, or to implement a SQL interpreter atop whatever their data store is. So for read purposes, it's important that that you essentially write your application to a specific backend and then take advantage of that backend's functionality as you need to provide the best user interface for your users. Again, Zcash client backend is built with the idea that, okay, there are these things, scanning, transaction construction, and so forth, that are common across wallets, but there is a lot of functionality that is really going to depend upon the user interface that wallet wants to provide, and the low-level implementation that can then provide that. So mostly you'll use Zcash client SQLite just via the Zcash client backend interfaces, but it then is a sort of further opinionated implementation of those interfaces. And again, for a list of transactions, you'll go to the vTransactions view. For a list of outputs in transaction, you'll go to the vTXOutputs view. And there are a number of views that are expressed as part of the public API here. But the public API, not the Rust API. And we do treat breaking changes to that public API of the views in this, in the same way as we do some breaking changes in the Rust APIs. We describe the views that are exposed here. All right, Alfredo.
Yeah, sorry. So I noticed in the past that people had to fork these crates to make their own modifications. And what you're explaining about that you can implement a version of the trait in your own crate seems like a good thing to do. And I was wondering if that has changed in the last time. So the idea is people do not have to modify the crates themselves and can do
well, okay, so
they can. Yeah, go ahead.
Hopefully, so if there are modifications that you need in order to support your use case, we are absolutely interested in talking to you and improving the common APIs. There have been modifications that we've had requested in the past that we have declined to make because there were already ways, there were already mechanisms provided to achieve those goals via the APIs that we exposed. And in some of those cases, we felt that the API surface that was being requested was essentially a workaround for maybe some other inadequacy in the APIs that needed to be corrected. So when we've declined those kinds of contributions in the past, there are some where I know that some people have, for example, forked. Han has forked these crates provide is Y-wallet support. And there are things that are required for Ycash support that we haven't been interested in implementing in Zcash crates, because it would expand our API service and expand our maintenance responsibility without providing utility to Zcash users. There have been other things with, for example, key management, where in the past, so we tend to expose functionality in a very incremental fashion, where at first we expose sort of the minimum functionality that we think might be required by users. And then over time, we discover that, okay, maybe that was actually inadequate. So one example where that's happened recently is in the orchard and sapling crates, we had to expose functionality that we had initially considered to be too low level to be generally useful, in order for us to implement pieces of T support. So what I would say is that if you have a specific motivating use case, and there's no alternative, then you may need to fork the crates, at least initially. But if you can, when suggesting changes, if you can take into account how newly exposed APIs might potentially be either intentionally or accidentally misused, then we'll be much more amenable to including those changes, essentially if they're safe. We hold ourselves and other outside contributors to a fairly high bar with respect to protecting our users and their users. So, and we will absolutely try to work with you to suggest, alternatives or workarounds if you find yourself unable to do what you need to do. Go ahead, Alfredo.
Yeah, sorry. I know we are over time.
That's fine. I fully expected this to go a bit long. So, yeah.
Okay, thank you.
It's all being recorded. So anything that you miss, if you need to drop anyone, it'll all be on the recording.
Okay, cool. So I was wondering that with the new 7 that is going to have shielded access support and the memo bundles, I hope that people start to building more on top of Zcash, and I assume that they are going to be needed, all these crates that we are talking about. So let's say, for example, you want to build some sort of exchange or a chat system or storage with the memo bundles. What are the crates you need? You need the full stack, or you need
two or
three of them for a basic use case?
It really depends upon what you're wanting to do. If you need chain scanning functionality, then you will likely want to use the crates up to Zcash client backend. If you don't need chain scanning functionality, then it would be hard to think of a use case where that wasn't included, essentially. So we provide, that's probably the starting layer for most applications, I would say. And as I mentioned before, Zcash Dev Tool, I mentioned it in the context of pieces of T, but Zcash Dev Tool also includes a complete wallet that's built on top of the Zcash client backend and Zcash client SQLite crates. And so it also serves as a reference implementation there. And at the upcoming ZCon, I'm going to be giving a talk about Zcash Dev Tool specifically in the context of, if you want to hack on Zcash, here's how you can use Zcash Dev Tool to prototype your functionality. Yeah. For for more sophisticated users, for example, Brave is building directly atop Zcash primitives and Zcash keys, I believe, and they're not using anything in the stack above that. But that may not actually have been the best option for them, because it does introduce some extra complexity. All right. Any other questions? All right, I know that was a whirlwind and that there's a lot here to absorb. If you have any questions, please feel free to ask. And if there are places where you find the documentation coming up short, please feel free both to ask and to contribute. Our documentation can always be better, and getting involved with documenting things is a great way to start off your Zcash journey.
Where should we ask?
The best place is going to be on the Zcash R&D Discord channel. In probably the libraries channel is the best place there.
I knew the answer. I just wanted it on the recording.
Yep. Paku?
All right. Well, first of all, thank you, Chris, for pulling this out, and all the team. I see that you worked a lot to make this as smooth as it has been. This will be a great resource for the whole community, and I hope that a lot of new people can be welcomed with this incredible walkthrough. One thing, you partially said it, but like one thing that would be interesting is to wrap up with like some calls to action for new devs that want to become involved on like contributing, and what are the good first issues, what things they should look at first to get their feet wet and start building with these tools.
Yeah. So for that, for a new dev who's just wanting to start getting their feet wet in the Zcash ecosystem, I would recommend playing around with Zcash DevTool and watch my talk at ZCon, because that is essentially the highest level interface that we provide, and it's that tool is intended to be both a reference implementation, but also very readily hackable. It's built so that essentially all the parts of the scanning and transaction creation and wallet management process are broken out into individual CLI commands, and they're all effectively atomic. They are stateless, so you don't have a running process you have to interact with. You can just say, do one thing against the wallet, or you can take a transaction and inspect it, or you can take one step of the construction of a PCZT, or you can make a proof for a PCZT. You can, we used it heavily in the Keystone wallet development, where all of the transaction signing functionality that was built around PCZTs was first prototyped in Zcash DevTool, so that we could treat Zcash DevTool as here's just a black box that is doing the signing. Now do our other APIs that are consuming the PCZTs and adding proofs and finalizing them, do those all work with a signature that's just coming from somewhere? So that's really the place for a new developer to start, is look at the individual commands that tool provides, look at their implementations, and ask questions. Go ahead, Paku. You're muted still.
Okay. Yeah, the UI was acting up on me. I wanted to just do this. Thank you.
All right. Thank you everyone for coming. And yeah, the other thing to just, if you need more high level summary, then the README in librustzcash now has a bit better information than it's had in the past. So
Thank you very much, Chris.
all right.
Thanks, Chris. Bye-bye.
Thanks everyone. Bye.
That was awesome, Chris.
Thank you.
Yeah. Thank you.